Hello, so today I'll be teaching how to solve a second order linear homogeneous equation with constant coefficients. I'm going to remind everyone that a second order equation looks like this. It's homogeneous when g of t is equal to 0. But here it's going to take the form ay double prime plus by prime plus cy equals 0, where a, b, and c are constant coefficients. Our solution is going to take the form y equals ert. We're going to get the derivative of that and then y double prime, and then substitute it back into our equation. After we factor out the ERT, we get that A R squared plus BR plus C is equal to 0. This equation is known as the characteristic equation. And it has to be equal to 0 since we know that E to the RT cannot be equal to 0. And this whole thing is equal to 0, so we know that this equation has to be equal to 0. We're going to get the roots, the value of R, by either factoring or using the quadratic formula or completing the square. Depending on our roots, we can get 3 possible cases. And we're going to approach them differently to solve our problems. So we can get that R1 and R2 are both real numbers and they are not equal to each other. We can get that R1 and R2 are real numbers, but they are equal to each other. So they're going to be repeated roots. Or we can get that R1 and R2 are complex, which involves imaginary numbers. Here are the general solutions that we're going to be using for each of these cases. And so we're going to go to the first example now. This example involves 2 real roots that are not equal to each other. It's the equation is y double prime plus 4y prime plus 3y is equal to 0. And we have the initial conditions, y of 0 is equal to 1 and y prime of 0 is equal to 0. We're going to plug in the y equals ERT into our equation. After we factor out the ERT, we get that our characteristic equation, which is equal to r squared plus 4r plus 3, and it's equal to 0. We get our roots that are -3 and -1. We get these 2 solutions that we can then plug in into our general solution. And so we get that y is equal to c1 e to -3t plus a2 times e to -t. So now we're going to want to find the solution to this specific initial value problem. So we're going to get the derivative of this. We get that y prime is equal to -3 c1 e to -3t minus c2 times e to -t. We are going to get the value of c1 and c2 using these 2 equations. After plugging in our zeros, we get that c1 plus c2 is equal to 1, and -3 c1 minus c2 is equal to 0. We do some algebra and we get that c1 is equal to -1/2, and c2 is equal to 3/2. So our solution turns out to be y equals -1/2 e to the -3t plus 3/2 e to the -t. So our second problem involves 2 real repeating roots. So R1 and R2 are equal to each other. So here we have y double prime plus 8y prime plus 16y is equal to 0. We have the initial conditions y of 0 equals 1 and y prime of 0 equals 0. We plug in our y equals ERT into our equation, and after factoring it out, we get that this is our characteristic equation, and the root is going to be -4, so it's repeated root. We are going to get that these are our solutions, and as you can see, this one has a v in it. V is going to be our multiplying factor, and I'm going to teach you how to find it. So to find v, first we're going to want to get this equation, and we're going to get y prime and y double prime of this. So after you do, we're going to plug this back into our original equation, and then we're going to factor out the e to the -4t. After we do that, we get this equation that we can then expand. And after doing that, we're going to realize that most of the terms cancel out, and the only things that are left are going to be e to the -4t times v double prime. Since we know that e times e to the -4t cannot be equal to 0, we know that v prime must be equal to 0. So we're going to find v by integrating. We get that v is equal to c1 plus c2t. So then we plug in our root into this equation, and we get this general solution, c1 times e to the -4t plus c2 times t times e to the -4t. We're going to find C1 and C2 by getting y prime of this solution. So once we do, we then plug in our zeros and we get that C1 is equal to 1 and that C2 is equal to 4. Therefore, our solution is going to be y equals e to the negative 4t plus 4t times e to the negative 4t. We are now in our last case, which is when we have two complex roots, which usually happens when we have a negative under the square root. And our roots are going to take this form. They're going to look like lambda plus or minus I mu. So here our equation is y double prime plus 4y prime plus 8y equals 0. With the initial conditions, y of 0 equals 1 and y prime of 0 equals 0. We're going to plug in the y equals ERT. We're going to then factor that out. We get our characteristic equation. And then we find the roots by using the quadratic formula. Here our roots are going to be negative 2 plus or minus 2i. So we know that lambda is equal to negative 2 and mu is equal to 2. So we know that r is equal to our roots. So they're going to look like this. And then we can separate that. And we have an equation formula for this, which is called Euler's formula. So E times to the I mu t, it's equal to cosine of mu t plus I sine of mu t. And with this, we can get y1 and y2. But we want real solutions. And we know that the addition of or subtraction of the solutions also gives us real solutions. So we're going to do y1 plus y2, which is going to give us 2e lambda t cosine of mu t, and y1 minus y2, which is going to give us 2ie lambda t times sine of mu t. We're going to ignore the constants, and then we get our general solution, which is this one. We can then plug in our values for lambda and mu and get y is equal to e to the negative 2t times c1 cosine of 2t plus c2 sine of 2t. This is our general solution. We're then going to get the derivative of this so that we can find the solution to this initial value problem with the conditions that we were given. After plugging in our zeros, we're going to get that C1 is equal to 1 and C2 is also equal to 1, which is going to give us a solution of y equals e to the negative 2t times cosine of 2t plus sine of 2t. Thank you.